Okay, so hello everyone, welcome to the talk. I am Dario, so this one here among these names, and this is a talk about joint effort that we are making inside the virtualization team BCL together with Jim and also our team lead, no less, Claudio, to try to understand things like whether we can kill that nasty thing called NUMAD, whether it can be, maybe because it can be replaced by automatic NUMA balancing, but I mean, we will see. So this is again, and I'm saying again because I talked already about this morning during the first talk in the other room, the SAP HANA KVM one. So this is again about tuning virtual machines, trying to achieve good performance, as good as possible performance from workload running inside virtual machines. And again, one very effective way of getting to that point is, let's say statically for now, it's partitioning the host and then statically assigning host resources to the VM. This makes the VM run fast for a bunch of reasons, but also removes some of the bonus points of virtualization, like flexibility and stuff like that. So very quickly, servers these days have topology. Well, they always had, I guess, but we have all sort of things. We have NUMA nodes, meaning that we have memory with access latency, which is different depending on from which CPU you are accessing which memory locations. We have different cache levels, different level of sharing of both memory and also computing resources with, for example, hyperthreading. So basically, this is the same representation of the topology, this time with these drawings, which I will continue to use in the rest of the presentation. But yeah, point is that there's a lot of sharing in modern computing, let's say, and as I said, both at the actual computing level with things like hyperthreading and at the let's say in the memory hierarchy, let's say, with different level of caches and also with NUMA, which is actually, or in some sense, sharing. So the memory is shared among the CPUs that are part of the same NUMA node is not, at least in terms of performance, let's say, among CPUs that are in different NUMA nodes. So yeah, if we can enact a bunch of measures, let's say, which is statically pin the virtual CPUs of a VM on physical CPUs. We, for example, remove all the latency and potential performance penalty in terms both of absolute performance and also on variability that comes from scheduling at the host level. Then we do the same for the memory. Then we, at which point we can also, since we are statically assigning resources, we can also pre-allocate the memory and use 1 GB huge pages. We can pin other components of the virtualization stack. We can take advantage of the virtual topology, and I have a slide for it later, but I will just cover it quickly. Point is, what we get, at least hopefully, but I mean, for example, this morning talk about HANA KVM show that it can at least be quite effective, at least for some workload, is high performance, small overhead, consistent results, but we lose, so at the cost of more difficult and cumbersome management, because we have to decide and then specify all these things manually, and also some of the flexibility that virtualization instead usually provides. So the able of having a VM run on a bunch of different hosts without having to worry about these things, which functionally, I mean, remains the same, but don't get the performance improvements, of course. So yes, about pinning, this is a quick example. This is not, I'm just giving a quick overview of all these things. It's not the main topic of the talk, so I'm going to cover this very quickly. If there's time at the end or offline, feel free to ask questions or fetch me. So what I was saying about topologies that is that as you may know, the Linux kernel itself, no matter whether it's on bare metal or in a VM, has some tricks to deal with the topology, because hardware has topology too, of course, and so it has tricks to deal efficiently with hyperthreading, with NUMA, and all sorts of things. And if we do all the things that I showed before for a VM, then it means that we can take advantage of all these optimizations even in the VM and achieve good performance, achieve even performance depending on the work or depending on condition. This is always something that I have always to say. But achieving, I guess I can say, because we've seen it, achieving performance which are close enough to the one that you would get on the host. So all good, but you are losing the flexibility. So example, if you have an host like that, of course, that's again the representation coming from LS-Topo. It's not complete. That is much larger. There's a lot of stuff here in the middle where those 3 dots are. So it's a very large host with 4 nodes, 344 CPUs, and not so much, not that much RAM, but whatever, that's what we had. And let's say that we want to run 16 VMs there, and that we know that we are going to run 16 VMs. We know in advance the size of the VMs. We know that they will arrive at a certain time. We have good knowledge of the system we will be dealing with, even from the VM's point of view. So intuitively, I guess you can imagine that we can do something like that in terms of placing the VMs on the NUMA nodes and on the CPUs in this case, and in terms of what I was quickly sketching before. So partitioning the resources of the host in such a way that each of the 16 VMs have as much exclusive as possible, as much undisturbed by, for example, other VMs as possible, access to both CPU and memory from the host as its own, let's say, fraction of the host that it can use, and if that's possible, it probably performance will be good and stable, hopefully. Now, if we don't instead know all the things in advance, these are just confusing and simplified representation. But if we don't know everything in advance in terms of how big the VMs are, when they will be started, how many of them, then we cannot do all the partitioning and resource assigning that I mentioned. And we end up with different situations. In the worst case, we don't do nothing. We are in complete hands of Linux, of the host kernels, scheduling and memory policy and whatever. And we can end up with, very different situations. We can end up with, and of course, this varies over time. This is an attempt to capture as bad as possible, because it was fancy to show it like that, a snapshot of some situations where VMs are running like this. So there are VMs running already on 4 VMs running already on this node, but then for some reasons there are more than 4, and there are some running on VCPUs. The VCPUs of the VM are running some some of them on the physical CPUs of this node, and some other ones on physical CPUs of other nodes, and all these kind of theoretically bad things, which, as I said, you can avoid with manual tuning. But if you don't want to do having to do manual tuning all the time, can we avoid? That's the point. So let's look at it. Can we do something like that? So if we don't do nothing, then we get what I just showed. We get that the Linux, of course, it's not like the Linux kernel scheduler at the host level is completely crazy and will deliberately go against anything that it would be good for the VM, but doesn't have the knowledge coming from tuning to optimize things. So basically, we can end up with virtual CPUs of the VMs running pretty much everywhere, according to load balancing logic, of course, of the scheduler, but acting and active at the host level, which might not take into account that some of the tasks which are moved around are tasks which are representing virtual CPUs of one same VM. And so we can end up in situations like I show where they run on different NUMA nodes and stuff like that. The memory is allocated from where these tasks run for the first time, and so it can be also spread across NUMA node and accessed either locally or remotely at different times without us being able to know or control, and stuff like that. This is an example of VM started without any tuning, and you can see that they got memory from all the nodes. And if I would show you, if I would show you the vCPU pinning, there is none. So vCPUs of these two VMs can run everywhere. Now, automatic NUMA balancing. It's a feature of the Linux kernel since quite a while, with an even nice history, but let's not go into that. There's no time. Of conflicting implementation, then I think it was Mel that reconcile both the implementation and also people fighting for them. It's like host kernel doing some magic tricks in order for automatically try to avoid what I just showed before. So basically, it's like try to figure out at runtime dynamically if some memory is being accessed from tasks which are running on another NUMA node, then maybe we can move the memory on the NUMA node where the tasks that are accessing it are running, and so make the access local. Or vice versa, we can move the tasks on that other NUMA nodes. And there are a bunch of heuristics. It depends if the memory is accessed by multiple tasks. We don't go into details. It's a while that it's there. It's been fine-tuned. It's working quite well, even from the preliminary benchmark that I have run for this presentation. There is one thing, though, which is something that we may want to use, that it proves useful depending on the workload, of course, but it usually does for VMs, is using huge pages and, if possible, pre-allocating them from huge TLBFS. So we can use effectively 1 GB huge pages and stuff like that. And if we do, then this super fancy, super cool, very effective automatic NUMA balancing mechanism, it's not kicking in for those pages. They're not touched. And yeah, this is what we say about it in our documentation. We say it's very interesting and useful and effective. Otherwise, however, if possible, it's still recommended to check if we can tune things manually. So yeah, is this a solution for our problem? Well, yes and no. It's not, for example, if we know that for the workload at hand, we want to use huge pages pre-allocated this way. So maybe we can look for something else. There is another tool. Also, I didn't check when the development started of this tool called NUMAD. which basically something that tries to do pretty much the same thing that I just described that automatic NUMA balancing does, but in user space. And it does it changing monitoring more or less the same thing. Of course, it's probably, we can probably say that it's a little bit more difficult to do that in user space, but it sort of managed to do that, or at least that was the goal. And it also tried to take the same measures, moving the tasks or moving the memory. And it does that by changing the affinity of the tasks or changing the memory policy, and then the memory is then migrated. Which again also sounds interesting. However, let's note that, yeah, there's a clear, it's basically the same thing that NUMA, the automatic NUMA balancing is also doing. So who knows whether we can use them together, or if they maybe might even conflict and create more problems than solutions. Actually, there is one additional problem, which is that NUMAD still exists even in our distributions, but it's not really developed any longer upstream since, I think, 2017, something like that. And in fact, a lot of those streams, including us, while still shipping it, we have already deprecated it in a couple of SLI releases. And either SP7 or 16 would have been the one where we were actually getting rid of it. And yeah, other downstreams like Red Hat or Ubuntu, they do ship it. But yeah, the upstream situation is not so great. So everyone, including us, has quite a few downstream patches, and of course, all different between different downstreams. So yeah, not great. However, what NUMAD can be used for is, I think it's just the next slide. No, it's not. Yeah, let's go to the next slide. This situation that I described about NUMAD upstream status and everything actually shows. So, for example, this is, to be honest, tumbleweed and not an SLI. But if you just install the NUMAD package on tumbleweed and you just try to use it like this, which may seem strange, the syntax, but don't bother. It just it's either invoked by libvirt, or you can even use it like that. But the interesting part is not understand what this command do, is to understand that you just call it and this seg false immediately. And we also have seen it causing problems. Just put their reference to a couple of nasty bugs, which were all due to NUMAD being there. So we probably really don't neither want it nor are in a good position for continuing using it, especially in its runtime, for its runtime functionalities of moving the memory and stuff. However, we can use it, or maybe even better, we can extract a subset of it and then use it, hopefully then maybe even improving it, or let's see if it will be improving it or rewriting it. But the concept, at least, it's that one, for initial placement of the VM. Because, yeah, as I said, if we know everything in advance, we can do things, we can do also the placement and the partitioning of the resources manually. But if we don't, then maybe this idea and these capabilities of NUMAD of trying to figure out what's the situation, what's the current status of the system, how many VMs are there on each NUMA node, how much memory free there is on each NUMA node, and then decide a new VM is being created. We know how big it is in terms of vCPUs and memory. We can decide where, or try to give our best guess, about where to place it, for example, in terms on which NUMA node, and hope that this will buy us at least some of the performance benefit that we are getting by manual to read. Maybe not as much, probably not, or at least not if we also don't then enhance it even further and involve other components, but maybe some of it. So that's basically the idea right now, which, yes, it's actually coming from an actual customer bug, but then starting to think about it and realizing that if we were really just removing the package, we were also losing this part, which in theory at least seems reasonable and good. Remember that what I said about pre-allocated huge pages. NUMA balancing is effective, but in that case doesn't do anything, it doesn't touch them. So instead, with this is actually an example of VMs which are using, which are baked by huge TLBFS huge pages, and you can see that the memory is allocated for each one on a different NUMA node. So it's very similar, after all, to what you would do manually if you would have to tune this system for running this for VMs. Of course, it's a simple case, but yeah. So we have thanks to both Claudio and Jim, we have a preliminary implementation of this set of functionality extracted from NUMAD, and I tried to use it for run some preliminary experiments, which really are still preliminary because there are things which I don't understand and I want to understand, and so I will continue to dig in the results that I have already and probably run even more. But still, CPU-bound workload, so no memory involved, let's say, at least as an approximation. The host is not oversubscribed because we have in total 16 VMs with in total 320 vCPUs, but we have 345. Different loads because we are running different number of threads inside of the VMs of this T-bench benchmark. And the different scenarios for these, but also for all the graphs and for all the benchmarks that I'm going to show in the rest of the presentation, is this one. So the blue histogram is neither replacement via our NUMAD hack nor automatic NUMA balancing are active. Orange is no placement, but NUMA balancing is active. Then the yellow is placement via NUMAD replace, that's how we are calling it for now, but no NUMA balancing active. And green is both placement and balancing. Of course, considering again what I said about huge pages, from some of this configuration we expect them to be basically identical, but yet I designed the benchmarking campaign for running all the cases, and so I have the results and I'm showing them, which is probably what's happening here, because we are using huge pages. So whether or not automatic NUMA balancing is active, it's probably doesn't make much of a difference. And in fact, that's what we see. Then also because this is a CPU-bound workload, but yeah, makes sense. So what do we see from here? We see that, doing some initial placement, at least on average, and when load is high enough, helps a little bit. Although, the error bars are standard deviation, so it's an improvement. We want lower, it's the time it takes to run the benchmark, so we want lower values. So, it improves things, but not in we cannot be really conclusive about it, considering the variation. And yeah, this is just larger version of the previous graph. Now, what happens if, so this was the average duration of this benchmark, and I mean the average across all the runs done in all VM, and then the average across all the VMs, because I have 16 of them. What happens if we take the maximum, so the slowest runs inside of each VM, and then it's again the average across all the VMs? Yeah, maybe it's even more evident that because I'm looking at this part here where the load is high enough, and I see that the cases where initial placement is active are lower again at zero average. There are still a little bit of variation in the results, but they are on average better than the cases where there is none. So all good so far. And also, perhaps let's look at these cases as well, which are, yes, slower, but here we also see that the variation of the results, the standard deviation is smaller, which is also something that we expected and that we would want for something like this. Now, let's overload the system, not from a memory point of view, so we are not allocating more memory than what we have on the host, but we are running more CPUs by just not increasing the number of VMs, but increasing the number of vCPUs of each VM. So now we have 384 in total. From here, it looks like the situation is kind of the same, still results, still variable results, but still a little bit better on average at least. If we look at the maximum, well, we have very unstable results in all cases, including, for example, look at how absurd is this one. Even if we have pre-placement active. So yeah, I mean, it's probably not the solution to all our problems, but yeah, maybe we still. Okay, let's move on to others. So yeah, this is another weird one. It's another one that I want to understand better, because this is stream, which are memory only, let's say, workload. And what puzzles me is, and in this case, we want high boxes, high rectangles, because it's throughput for various operations. And the stream is very quick, so what I did expect before seeing the actual numbers was that, again, preliminary placement of the VM on NUMA nodes would help at least a bit. We are using huge pages, so in theory, automatic NUMA balancing can do much. And yet, apparently it does, or maybe it's something else that produces these results. So, and also stream is, even if we forget about this, stream is very quick as a benchmark. It runs very quickly. So I was expecting, even if NUMA balancing were effective, to not be able to act in time and be able to achieve better performance than static placement, or but yeah, apparently there's something else to discover here. Yeah.
I think this should be the NUMA balancing effect should only affect the user partitioning.
Yeah.
I think the NUMA balancing part should only, or if it's with huge pages for the VM, it should only affect the QEMU user part then.
Yes,
probably because only because the VM memory is
the part that is not huge pages. Yes, it's affected by
and this is basically the test is running only for a short time, so copying the memory, moving the memory is dominating for the QEMU part, basically.
Yeah. Okay, now the other bench, I have two more, and then a different setup. So since we are a little bit short on time, this is me attempting to run spec JBB 2015, but yeah, I kept the results, but I want to, well, if not skip it, just quickly cover it, because for running this benchmark, I'm using MM-Test, so the tool from the performance team, and I hacked it in order for it to be able to run benchmark inside VMs. But in the case of spec JBB, it's not great yet, because there is a phase of the benchmark where the database is prepared, and then the actual benchmark start, and what happens is that the actual start of the real benchmark operations are not properly synchronized among all the VMs, so the results are not really interesting. They seemed good, at least these max JOps thing, but I don't think we can rely on them that much. So instead, the earlier version of spec JBB share the same problem to some extent, but a lot less, based on how the benchmark runs. And so again, this is one other situation where we seem to see that replacement seems helpful, because results are more stable and a little bit better on average. The other one that I want to show is this one, which is a slightly different configuration, well, more than slightly probably. So instead of 16 not so big VMs, it's only 2 VMs, but very large, to the point that all by themselves, they are covering the entire system by having 162 vCPUs and quite a bit of memory, and meaning that for when we place them correctly, let's say, each one of them have to span 2 NUMA nodes. And as you can see, this is even more evident of a situation where doing some placement helps, because especially again when the load is high enough, we have the placement enable cases going sensibly faster than or I mean, having higher throughput of the other ones. What happens if we instead get rid of, and I don't have all the sets of the same benchmark, I only have a few of them, get rid of huge TLBFS huge pages, and we try with transparent huge pages. Then we discover that, at least for this workload and at least for this preliminary run that I did, then that actually it's true that automatic NUMA balancing is quite effective, because we see, for example, well, this is again 2015, so let's not look at it, but even if you look at 2015 variant of spec 2005, sorry, variant of spec JBB, we see that in this case, well, I guess we can say that having done placement has become rather uninfluent, because the configurations with automatic NUMA balancing are able to pretty much catch up. So that's the situation experiments number-wise so far. What can we say then? Well, I think that we saw at least a few cases for which we can say that doing some kind of replacement of the VM could be helpful. And so maybe it's not worthwhile, maybe it's not good thing to completely lose the feature. And so we may want something like that going ahead. At the same time, because of all the bugs, because it's unmaintained, because of all those reasons, we don't want to keep having NUMAD especially running as a daemon. So we are thinking, but I mean, we are open to feedback, to continue on this effort of putting something there which at least could be used and effective for the initial placement. What it needs to be, what it would be, well, for now, it's basically, as I said at the beginning, us carving out the pre-placement functionality of NUMAD and isolating it in a different binary, but yeah, and using it. At the same time, we are trying to understand what it does. There are a lot of heuristics there, and there are a lot of things that, while we are working on it, maybe can even be changed or improved. And yeah, and this is if you want to factor in all the possible aspects, it's a complex multi-objective optimization problem, because you can imagine a bunch of different situations, like I don't know, just to throw out some examples. You have our you have a VM with 4 virtual CPUs. The host has hyper-threading on. As we know, threads are not proper CPUs. What do we do? Shall we give the VM 4 physical CPUs, meaning 4 threads? Shall we give it more? Right now, for example, by default, NUMAD gives the VM more than that, because it does this consideration that hyperthreads are not proper CPUs. But is it something that we want, that we always want? We want parameters, or another point. We have a VM that can memory-wise and also vCPU-wise, let's say, fit on both node 0 and node 3. And perhaps we have a different amount of free memory in node 0 and 3, but the VM fits in both. Where do we put it? Do we use the CPU load? Do we use the amount of free memory? So there are a lot of these things, which of course I don't want to ask to solve it here now, but that will be relevant for the performance and the VM density that we can achieve if we continue. It also depends on how much time we will have to devote on this. And maybe if we can, I don't know, we can even try to revive some interest from the upstream community on it if we manage. That would be interesting, in my opinion. And yeah, that's basically it. Because as I said, I already basically said, explained already what the conclusions are, that we think we want it and we'll continue to try working on it, but we have to decide how, basically. So I think we have some 5 minutes at least for questions or feedback. So if there's anything.
I think that there shouldn't be a big problem to allow NUMA auto-balancing on huge TLB pages, especially if there are some, if there is a reserve, they're pre-allocated more than you are actually using. So that shouldn't be a big change. But one thing that I'm not sure I understand it, why do you, what's the main reason of using NUMAD for that logic? Are you benefiting from those heuristics that were developed inside of that tool, or you just don't want to replicate them in libvirt, or I mean, because you can achieve the very same thing without the package and all the baggage that it has of unmaintainable or unmaintained code. So can you explain that part?
But what you mean then is to write something else from scratch.
Yes,
that's also possible.
Without that baggage, because I'm not really entirely sure why that package has been, or that tool has been abandoned, but I believe that the maintainability cost just was not worth it. So,
The code is not great.
yes.
And I'm saying not by saying not great, I'm being nice to to the code itself. So yes, for now, the only reason is that it was there. There was this bug. This made us realize that fully deprecating it, we are losing something, and so we wanted to have something to try quickly, and so that's what we did. We are already, not only trying to understand and to improve it, but also considering whether it's worthwhile keeping it or writing a new one from scratch. There's also the point that right now it's basically a standalone program, which libvirt calls, and the output of the program is the placement advice. Does it have to be like that? Can it be integrated in libvirt? Is it better for it to be a standalone program? Is it better for it to be part of libvirt? Maybe inside libvirt it could have access to more information like what VMs there are around. Well, it can as a standalone program by shelling out virtualization, but come on, and things like that. On the other hand, will the libvirt community be happy, or will we be able to build it in a way that libvirt, because libvirt, would it sound too much of a policing thing? So there are a lot of open questions, even from that point of view, but it's not absolutely automatic that we will continue to try and keep it as it is and only fixing it as much as we can. It's definitely open. The possibility that we just rewrite it. It was just to establish that the functionality we probably wanted.
Maybe I missed it, but does this cover virtual machines that are bigger than one NUMA node?
Sorry,
so
virtual machine that?
Does this work for virtual machines that are bigger than one NUMA node?
Sure.
Okay, so what if the workload wants to know where its memory is to create good core to memory mappings?
So if a virtual machine needs to cover more than one NUMA node because it has, for example, more memory than how much memory it is in one NUMA node, or more vCPUs than how many CPUs there are in a NUMA node, then for now NUMAD, but our future tool, okay, will just tell you use two if it fits in two, and ideally also which ones.
Okay.
Probably also taking into account at the point when you start considering more than one, the distance and all these kind of things. What you wouldn't have at that point would be the virtual topology of the VM matching on, so a virtual NUMA VM, so the VM, will the VM know that it's running on two NUMA nodes, and then with a virtual topology be built for the VM that match? Then again, for doing that, we need to tell libvirt not only to return the advice, put the VM on node 0 and 3, but also to change the VM configuration at libvirt level in order to create a virtual topology. Is it possible? Sure, everything is. And it's something that we may want to try doing. It's not there yet, sure.
Okay, thanks.
That's it, I guess. Thank you again, then.